Good afternoon to everyone. In today's class, we are going to see the EMF equation of a DC generator. So we know that DC generator is a machine which is used to convert the mechanical energy to the electrical energy. So here, this DC generator works on the principle of dynamically induced EMF. Dynamically induced EMF. Here, dynamically induced EMF means the way of inducing the EMF is based upon the rate of change of the flux linkages. Rate of change of the flux linkages in the conductors. So for this, the EMF equation, we need some terminologies. The first one, the number of poles will be considered as capital P, and phi is the flux per pole, which is measured in the number of Webers, and Z is the total number of the conductors, especially the armature conductors, and A is the parallel paths of the conductors. Here, for the parallel paths, we are having two varieties. First one is the way of winding wounded. So first one is the wave winding, where the number of parallel paths are considered as 2, and coming to the lap winding, it will be equals to the number of poles. Okay, it will be equals to the number of poles, and N is the speed of the rotation of the armature, which is measured in the RPM, and capital EG is nothing but the EMF generated or induced in the armature conductors. Okay, armature conductors. So to calculate this, the same formula, as per the EMF, as per the Faraday's laws of electromagnetic induction, the average EMF induced in the conductors, will be equals to the d phi by dt. Average EMF induced in the conductors will be d phi by dt. Already we seen this one. So here, the change of flux to the change of time. So here, in one rotation, how much flux will be varies, we need to know. So the change of flux we given based upon the flux linkage per the poles. So the change of flux d phi equals the flux cut by the conductor in one revolution. So first, initially we are considering for the one revolution. Okay, it will be measured upon P into phi. And whereas coming to the dt, that is the time taken to complete one revolution. So previously I said the revolutions are mentioned in RPM. That means in 1 minute, we are going to perform n revolutions. That means in 1 second, we are going to perform 60 by n revolutions. The time taken to complete one revolution is 60 by n seconds. So by comparing this, d phi by dt, so p phi by 60 by n, so the final value will be p phi n by 60 Webers per second. Previously I said this will be also given in the volts. Okay, so here we are not considering a single conductor. We are having Z number of conductors which are arranged in a parallel paths. So each parallel path having Z by A conductors. So these are the parallelly connected elements. So the EMF generated across all these conductors are same. So this will be equals to the EMF generated for one conductor into total number of conductors connected in parallel. So it will be equals to the p phi n by 60 into Z by A. So where A is the number of parallel paths, based upon the winding, it will be varies. So this is the total EMF generated in the DC generator. Okay, I hope this will be useful for